Hello everyone, we are going to solve problem 111 of chapter 16. At a given instant, the slider block A is moving to the right with the motion shown. So for block A, we have everything. We have the velocity, we have the acceleration. We want to find the angular acceleration of link AB for alpha AB, and also the acceleration of point B. So these are the two unknowns. So the problem is not asking for the velocity at B or omega AB, but for writing the acceleration equation, we need those information. So even the problem is not asking us to do any relative velocity formulation. We have to do that to get the information needed for the second part of the problem. So VB is equal VA, VB with respect to A. VB at this instant, this one has a horizontal motion in this direction. So if I have my coordinate system, X and Y, VB would be VBI. If I want to write it in a vector form, has only one component at the given instant in positive X. VA is 4I. VBA is the rotational component, so omega AB cross, I don't know the value for omega AB, but I know that it's either clockwise or counterclockwise. It would be in the direction of, V or negative V. Cross RB with respect to A. So RB with respect to A means from A to B. So 2 cosine 30 will give me the X component, sine 30 will give me the Y component. Both of them would be a negative value. So that would be negative 3I and negative J. So if I expand that, I have VBI equals 4I. Omega AB KI would be negative 3 omega AB J plus omega AB I. So if I look at this vector formulation, I can see that on one side, I have no, if I write it for J component, on one side I have no J component. On the other side, I have negative 3 omega AB. That tells me that omega AB is 0. What does that mean when our link AB has no angular velocity? That means that our link AB has a translational motion. And whenever we have a translational motion, that means that any point on our rigid body have the same velocity. So if velocity at B is the same as velocity at A at that instant. Even the equation is telling us that if omega AB is 0, that means that VB is the same as VA or 4. So the other VB is 4 meter per second. So we're going to use these two information when we are going to write our acceleration equation. The second part of the problem is asking for acceleration. ABAA plus AB with respect to A. For AA, we have everything. It's a linear motion. I need to find AB and AB with respect to A in a vector formulation. AB, if I clean up the image a little bit here, at point B, I only had one component of velocity, but I have two components of acceleration, one the tangential component, one the normal component. And the normal component is VB squared over rho, the radius, which is here is 2 meters. And the tangential component, I don't know the value yet. So for AB, I write AB TI negative VB squared over rho J is towards negative J. A, I know the acceleration at A is 6I plus AB with respect to A. So for here, I have two components as well. I have alpha AB cross RB with respect to A. That's the tangential component, and also omega AB RB with respect to A. I found omega AB to be 0. So the second component would go away. So if I just write this equation, AB, I don't have it. Velocity at B, I found is 16. It's 4 squared 16 divided by 2, 8, negative 8J equals 6I. RB with respect to A, I found it up there. So cross product would be negative 3 alpha J plus alpha I, which is alpha AB. That's the only alpha that we have. So just write it alpha. So if you write the I component and the J component, alpha will be 4.62 radian per second squared, and AB, or tangential component of AB, would be 10.62 meter per second. So AB has two components. So if I want to find the acceleration, I need to consider both components. 10.62 squared plus the vertical component, or the normal component, was 8, or VB squared over rho. So it's 64. So overall, I have 13.3 meter per second squared. So for this problem, while the problem was not asking for any velocity of B or omega AB, I need those values to find the relative acceleration equation. So when you are solving such problems, you need to pay attention whether the problem has given you any information about omega AB and VB. If it's given, then you don't need to do it. But if it's not given, you have to do it, even though the problem is not asking for it directly. The other important point is that for acceleration, we always have two components unless it's just a horizontal motion, a linear motion. So for here, we had two components of acceleration that we had to consider, and also two components of acceleration for link AB, but one component was 0 because omega AB was 0.